Standard offset pagination forces databases to scan every preceding row before reaching your target, turning millions of records into a performance nightmare. At page 100,000, the database reads and discards 1 million rows just to return 20, causing execution time to spike linearly. Fetching deep pages saturates the buffer pool with discarded data, forcing meaningful records out of memory and degrading overall system throughput. Keyset pagination, also known as the cursor method, avoids the scan by using the last seen value to jump directly to the next set. By using a where clause on an indexed column, the database uses a B-tree lookup to find the starting point in logarithmic time. Replace the traditional select star with limit and offset with a select query filtered by a unique identifier greater than the last value. Cursors must be unique and deterministic. If you sort by a non-unique field like a date, the database might return inconsistent results. When sorting by non-unique columns, append the primary key to the order by clause to ensure a stable and predictable result set.
Use row value constructors to handle multiple filter conditions cleanly. This allows the database to compare tuples in a single operation. If your database system does not support row value constructors, expand the logic into nested where conditions to maintain index usage. Design your indexes to cover the columns used in both the filter and the sort. This allows the database to skip table lookups entirely. Running a full count on millions of rows for every page load is a hidden performance killer that negates your pagination gains. Retrieve approximate row counts from system tables or statistics instead of performing a full table scan when exact precision is not required. Store current row counts in a separate metadata table. Update these values using triggers or application logic whenever records are inserted or deleted. For high concurrency systems, use an atomic counter in an in-memory store like Redis to track the total number of enterprise records. Offset pagination suffers from drift when new records are inserted on page 1, causing the same item to appear on subsequent pages.
Keyset cursors are immune to drift. Because the query is bound to a specific value, insertions or deletions do not shift the result window. To navigate backwards with keyset pagination, reverse the sort order and the comparison operator, then flip the result set in your application. Include next and previous cursor links in your application programming interface response. This follows hypermedia principles and simplifies client-side logic. Infinite scroll thrives on keyset pagination. As the user reaches the footer, the last identifier is sent to fetch the next batch seamlessly. In large-scale enterprise resource planning systems, use virtualized lists to render only the visible rows, preventing browser memory exhaustion and lag. Throttle your scroll event listeners to prevent the application from firing hundreds of unnecessary fetch requests during rapid user interactions. Predict the next user action by prefetching the following page cursor when the user stops scrolling, resulting in an instant transition experience. First, retrieve only the identifiers of the records you need. Then, join those identifiers back to the main table to fetch the full details.
Deferred joins reduce the volume of data the database must process during the initial sort, significantly lowering read input-output operations per second. For complex reports that rarely change, paginate over a materialized view. This pre-calculates the sort order and stores it on disk for speed. In distributed databases, global pagination requires a merge sort of the top results from every shard before returning the final page to the client. The coordinator must receive n records from each shard, where n is the requested page size plus the offset, creating a massive data bottleneck. Keyset pagination solves the distributed bottleneck by allowing every shard to use the cursor to filter their local data before sending results back. For extremely high-volume enterprise data with complex filtering, offload pagination to dedicated search engines like Elasticsearch that are optimized for deep paging. Use the search after parameter in your search queries. This function works identically to keyset pagination, ensuring consistent performance across large indices. Avoid caching entire pages of results. Instead, cache the underlying data and cursors to ensure users always see the most recent system state.
Most users never visit page 10,000.
Consider replacing total page counts with a simple Show More button to reduce database load. If business requirements mandate jumping to a specific page, use a hybrid approach where offset is only permitted for the first few pages. When users apply multiple filters, your composite indexes must include the filter columns first, followed by the columns used for sorting. Indexes on low cardinality columns, like status codes, are inefficient for pagination. Prioritize columns with high uniqueness to speed up the cursor lookup. Avoid including binary large objects in your paginated queries. Fetch only the metadata and use a separate request to retrieve the heavy content. Use the explain analyze command to verify that your pagination logic is using the intended indexes and not falling back to table scans. If you must show the total record count, cache the value for 5 minutes to prevent redundant scans across every user request. Standardize your pagination parameters across the entire system. Use consistent names like cursor, limit, and direction to reduce developer confusion.
Implement robust error handling for invalid or expired cursors. If a cursor is malformed, the system should default to the first page safely. Keyset pagination reduces lock contention during heavy writes. Unlike offset, it does not require a stable scan of all preceding rows. Be cautious with object relational mappers. They often default to offset pagination. You may need to write custom structured query language for cursors. Always test your pagination logic with a dataset that matches your production scale. A query that works on 1,000 rows may fail on 1 million. By eliminating offsets, leveraging compound indexes, and adopting cursor-based navigation, your system will handle millions of records with constant sub-second latency.